Hello everyone, welcome to the class. In today's class, I'll continue the numericals on study of gas law. Okay, so in previous video I have taught you till question number 8. Now let's see question number 9. I have written the question on board. A gas at 240 Kelvin is heated to 127 degrees Celsius. So Kelvin is the unit of temperature. So this is T1 and this is T2. Okay, find the percentage change in volume of gas. Pressure remains constant. Pressure is kept constant. You have to find the percentage change in volume. Pressure constant means you have to use Charles law. Charles law. Okay. If temperature is kept constant, then that means Boyle's law. You have to use Boyle's law. If nothing is kept constant, then you have to use combined form of gas law. Now, let's proceed with this question. Given this is T1, okay, temperature. T1 is 240 Kelvin. T1 is 240 Kelvin. T2 is equals to 127 degrees Celsius. See, it is in degrees Celsius and this is in Kelvin. In first video itself, I have mentioned that always keep the temperature in Kelvin scale. Okay, so let's convert this in Kelvin scale. It will be equals to 127 plus 273 Kelvin. When you convert, the relation I will give here, okay, because K is equals to C plus 273, okay, C plus 273. This type of conversions we have done in previous questions also. So when if you want to convert degrees Celsius in Kelvin, you have to add 273, okay. So I have added 273 out here. So it will be 7 plus 3 is 10, 7, 8, 9, 10, 2, 3, 4, 400 Kelvin. Temperature is, T2 is 400 Kelvin. Find the percentage change in volume of the gas. So percentage change in volume we have to calculate. That means percentage change in volume means V1 minus V2 or V2 minus V1 depending upon the magnitude of V1 and V2. If V1 is bigger, then it will be V1 minus V2, okay, and if V2 is bigger, then you have to use V2 minus V1. This gives change in volume. After that, you have to go for percentage change in volume. Percentage change in volume will be change in volume divided by original volume into 100%. Okay, change in volume. First of all, let's find change in volume. So V1 is not given, so let it be X. Let it be X. V1, let it be X. And V2 is also not given. V2 is also not given. Let's find V2 in terms of V1. Okay. So using Charles law, C alone I write. Okay. Charles law. Charles law says that V1 upon T1 is equals to V2 upon T2. This is the mathematical statement of Charles law. You note down this properly, okay? After this, put the value of V1. V1 I have supposed X divided by V2, divided by T1. T1 is 240. T1 is 240 is equals to V2. We have to calculate V2 and T2 is 400. So this 0 and 0 gets cancelled from denominator. 8 3s are 24, 8 5s are 40. If you cross multiply this, 3 into V2 is equals to 5 into X, 5X. So V2 will be equals to 5X upon 3. V2 is this. Now change in volume. Change in volume, VOLM. I'll write short form, okay. Change in volume is equals to, which is bigger, V1 is bigger or V2 is bigger. If you divide this, 5x divided by 3 will be 1 point something, 1.6 something, okay. So obviously this is bigger than this, V1. So V2 minus V1. V2 is 5x upon 3 minus V1 is x. So if you take the LCM, 3 is the LCM, 5x, 3 into x is 3x. So it will be equals to 5x minus 3x is 2x upon 3. So this is change in volume. Now let's calculate percentage change in volume, and it is this part. Therefore percentage change in volume is equals to change in volume divided by original volume V1, okay, into 100%. So change in volume is 2x upon 3. This change in volume is 2x upon 3, okay. Into this V1 is x, we have considered V1 as x, okay, into 100%. X and x gets cancelled. 2 into 100 is 200 divided by 3%. 200 divided by 3 means if you divide this 66, 2 by 3%. Let me check. 3 200. 3 6 are 18. 23 6 are 18. Okay, 2. 66, 2 by 3%. So this is your answer. Change in volume, percentage change in volume is 66, 2 by 3%. Okay, so in this way you have to solve this question. Now let's move on to another question. Question number 10. Question number 10 is, certain amount of gas occupies a volume of 0.4 liters at 17 degrees Celsius. I'll not write the question, okay. Again, I'm repeating the question. Certain amount of gas occupies a volume of 0.4 liters at 17 degrees Celsius. To what temperature should it be heated so that its volume gets doubled, number A doubled and number B reduced to half, pressure remaining constant? Okay, let me write the question. So question is, certain amount of a gas occupies a volume of 0.4 liters, LTS stands for liters, okay, at 17 degrees Celsius. So here the temperature is given in degrees Celsius, so you have to convert this temperature, okay. To what temperature should it be heated so that means to what temperature should it be heated, that means you have to find the temperature. T2 you have to find. This is T1, you have to find T2. This is V1, okay, V1, this is T1, T2 is question mark, so that its volume gets doubled. Volume gets doubled means whatever is the original volume, 0.4 is the original volume, double means into 2. 2 into 0.4 will be 0.8 liters, okay. Number A is this, and number B is reduced to half. Reduced to half means original volume was 0.4 and when it gets reduced to half you have to divide by 2. This divided by 2 gives 0.2. So reduced to half means V2 will be 0.2 liters. With this values you have to calculate the temperature, okay. So solution, number A, I'll do directly. Number A, given V1 is 0.4 liters, V1 is 0.4 liters, okay. T1 is 17 degrees Celsius. You have to convert this in Kelvin, so I to convert to Kelvin you have to add 273. 17 plus 273 Kelvin, okay. So it will be equals to 7 plus 3 is 10, 7 8 9, 290 Kelvin. T2 is question mark. T2 we have to calculate, and is to what temperature should it be heated so that its volume gets doubled. V2 is doubled means 2 into V1, that is 2 into 0.4 will be equals to 0.8 liters. Pressure remains constant. Pressure is kept constant means you have to use Charles law, okay, by CL, Charles law. CL stands for Charles law, okay. We have V1 upon T1 is equals to V2 upon T2. put the value out there. It implies V1 is how much? Where is V1? V1 is 0.4 divided by T1 is 290 is equals to V2. V2 is 0.8 and T2 is question mark. T2 we have to calculate. Okay. So numerator and numerator you can cancel here. 0.41 is 0.4, 0.42 is 0.8. So from here you can cross multiply. T2 into 1. Okay. T2 is equals to 290 into 2 will be 2 zeros are. Okay, I'll write 290 into 2. Cross multiplication. Okay, this much you can understand. So T2 is equals to 2 zeros are 0, 2 9s are 18, 1 is left, 2 2s are 4 plus 1 5, 580. This is in Kelvin. So this is your temperature. Therefore required temperature is equals to 580 Kelvin, or if you want to convert this in degree Celsius, then you have to subtract 273, or 580 minus 273 degrees Celsius. So it will be equals to how much? 580 minus 273 will be equals to 10 minus 3 is 7. And 7 minus 7 is 0. Or 5 minus 2 is 3. 307 degrees Celsius. So this, you can keep your answer in Kelvin or you can convert it in degree Celsius. So in your book, answer is given in degree Celsius. Okay. Now second part reduced to half. Number B, for number B, given you write same thing. Okay, instead of T2 you write V2, instead of V2 you write V1 divided by 2, that is 0.4 divided by 2, it will be 0.2 liters. So with this value you calculate on your own. Okay, by this put the value instead of this 0.8 here you write 0.2, it will be 0.2. So 0.21 is 0.2, 0.2, 2 is this. Okay, after this you can cancel numerator and this also. 2 1s are 2, 2 1s are 2, 2 4s are 8, 2 5s are 10. So if you cross multiply, T2 will be equals to 145 into 1 this side if you multiply. Okay, so it will be equals to 145 Kelvin. And if you want to convert this in degrees Celsius, you subtract minus 273. Okay, so your answer will come in negative. So this completes question number 10. Okay, next question, question number 11. Question says that a given mass of a gas occupies 143 centimeter cube. This is your volume. Okay, this is V1 at 27 degrees Celsius. This is T1 temperature, and 700 mm of Hg. This is P1 pressure. Millimeter of Hg means it is the unit of pressure. Okay, what will be its volume? V2 we have to calculate at, this is T2 and this is P2. That means everything is given, nothing is kept constant out here. Okay, so V1 is there, T1 is there, and P1 is also there. Temperature is there, pressure is there, and volume is there. So in this case you have to use combined form of gas laws. Okay, since all the three variables are given, temperature, pressure and volume is given, so we have to use combined form of gas law. Okay, let's write the given things. Given V1 is equals to 143 centimeter cube. T1 is 27 degrees Celsius. T1 is 27 degrees Celsius. This let's convert in Kelvin. 27 plus 273 will be equals to 300 Kelvin. 7 8 9 10 7 8 9 10 2 3. Okay, 300 Kelvin. P1 pressure 1 is 700 mm. I'll write mm only. Okay. What will be its volume? V2 we have to calculate at 300 Kelvin. T2 is given 300 Kelvin. 300 Kelvin. 300 Kelvin. That means temperature is kept constant. 300, 300. Again, I'll check it. Okay, 273 plus 27 will be 10, 7, 8, 9, 10, 2, 3. Okay, temperature is kept constant in this case. Temperature remains constant. Okay. What will be its volume at 300 Kelvin and 280 mm? Okay, P2 is equals to 280 mm. So by combined form of gas laws, we have P1 V1 upon T1 is equals to P2 V2 upon T2. This is the mathematical statement of combined form of gas laws. Put the value of P1 700, V1 is 143, T1 is 300 is equals to P2. P2, where is P2? 280 into V2 we have to calculate, and T2 is also 300. T2 is also 300. Okay. So 300 and 300 can be cancelled from denominator, and from numerator 0 and 0 you can cancel. And this also gets cancelled with 7. 7 4s are 28, 7 10s are 70. Again you can cancel 4, oh, okay, 2 2s are 4, 2 5s are 10. Now you cannot cancel further. So it will be 5 into 143 is equals to 2 into V2. So 5 3s are 15, 5 4s are 20 plus 1, 21, 5 1s are 5, 6, 700 divided by 2. This 2 goes down in denominator. Okay, equals to V2. Let me check 1 second. 143 into 5. 5 3s are 15, 5 4s are 20 plus 1, 21. 2 is left. 5 1s are 5, 6, 7, 715. So you can cancel 2 3s are 6, 2 5s are 10, 2 7s are 14. 1 is left. So 10, 2 5s are 10. So V2 is equals to 357.5 centimeter cube. Write down the conclusion properly. Okay. Therefore, required volume is equals to 357.5 centimeter cube. 357.5 centimeter cube is the required volume. Okay. Okay. Next question is question number 12. A gas occupies 500 centimeter cube at normal temperature. 500 centimeter cube. This is volume V1. Okay. At normal temperature means normal temperature NTP, normal temperature or STP. Let's got this pressure. Normal temperature and standard temperature is same. Okay. If you are said standard temperature instead of normal temperature, then it is also same. Okay. These two are same. Normal temperature means the value of normal temperature is 0 degrees Celsius or 273 Kelvin. So normal temperature means 273 Kelvin. So this is T1. At what temperature? At what temperature means T2 is question mark. T2 is question mark. Will the volume of gas be reduced by 20% of its original volume? So V2 is V1 minus 20% of V1. Okay. Pressure being constant. Pressure is kept constant. That means you have to use Charles' law. So given V1 is equals to 500 centimeter cube, T1 is equals to normal temperature is 273 Kelvin, because normal normal temperature means 273 Kelvin or 0 degrees Celsius. This you should know. Okay, I had given this in while teaching you the theoretical portion also. T2 is question mark and V2 is V1 reduced by 20% of original volume. V1 original volume minus 20% of V1. So V1 is 500 minus 20 percentage means divided by 100 of means into V1 is 500. So 20 gets cancelled. 500 minus 2 5 is at 1000. So it will be 400 centimeter cube. Okay. By Charles' law, V1 upon T1 is equals to V2 upon T2. So from here you put the value and simplify. Okay, you'll get the answer. Next question, remaining questions we will do in another class. Okay, so this much for today's class. Thank you.